How about interference from single slit? So when we have a single slit and a monochromatic light is striking through the single slit, the diffraction from the edges produces an interference pattern. What you see here is an interference pattern. Huygens principle says every point is a source and the direction is omni, like a sphere. But because the energy is moving on one side, that is why we see this round shape. So this is the pattern we have exaggerated. So this is the relative intensity, that is at the middle it will be higher. I am talking about a single slit. So middle one it will be higher, then it goes down and down. So the relative intensity and the fringes, I showed you how this is actually shown. So the interference results from the fact which we already discussed, that the light which is traveling, the path is different. That is, not all the path of the light travel the same distance. Some arrive out of phase also. In single slit interference pattern, we assume that all these points are by itself, they are source. That is, each point inside slit acts as a source. So now, when we take say rays 1 or 3 or rays 2 or 4, we can again go back to the basics and try to find out the distance between them. That is, we are going to call as the path difference. If you assume it to be a whole distance from up to down and take the middle one as a by 2, and we just assume that we have this 2 reds at a by 2 distance, what will be there? See, 2 rays are there, and when we have 2 rays, we need to have, because if you take the common distance, there is a path difference, that is, one might have traveled more than other, so there will be a path difference, and this is a by 2, this is theta, and this will be, if you assume this to be 90 degree, it is a by 2 sine theta, this path difference. So path difference, if you assume it to be dark fringe, let us say, so we know that it will be n into lambda by 2, n will be 1, 3, 5, like this. So a by 2 sine theta is n lambda by 2. This is for dark fringe. If you wanted the bright fringe, this will be a by 2 sine theta equals n lambda. Now n will vary from 0, 1, 2 like this. And here the dark fringe n will vary 1, 3, 5, the odd numbers. And in case of bright, there will be whole number. So if you cancel these two out, sine theta will be simply equals to lambda by a. So for other dark fringes, there will be integral multiple of this fraction lambda by a. You just have to multiply it through all the positive integers. Okay, so now if you see for, you can also find out for the white in the same way. Just you have to use n lambda. So this is for the first one. This is for the first dark fringe. Then we have second dark fringe, third, so you have to take the integral multiple. So in order to understand this, let us take a question. So we have a monochromatic light shines on a single slit of width 0.45 millimeter. So here we have 0.45. This A is 0.45. This is not 0.35, it is 0.45. So let me change it. Okay, this is A. Now, there are different symbols. So sometimes it is called as D, somewhere it is called as A. The screen is at around 1.5 meter and the first dark fringe is displaced 2 millimeter from the center, which is the central maximum. I showed you this is the central maximum and there are the fringes. The pattern is like this. So from the center, the distance is 2 millimeter for the first dark fringe, which is why we are calling here, why the symbol. Now sine theta is lambda by a, we just saw. As we already know, when the theta is very less, because these two, the path difference or the phase difference is too less, it's very small, it's very small. So we have this small difference, so theta is very small. In case tan theta will be almost equal to sine theta, because tan theta is sine theta by cos theta. When theta is 0, cos 0 is 1. So tan theta can be equal to sine theta. So since this is y and this is x, and if we take this angle as, so assume it to be y and x. So taking a triangle, this theta, tan theta will be what? Y by x. So which will be y by x. X we already know, y we also know. Sine theta will be what? I told you sine theta is lambda by a. Now sine theta is lambda by a. Just equate it to y by x. So y by x equals lambda by a. And this will be what? This lambda will be y into a by x. Lambda, see, y is 2 millimeter. So convert it into 2 into 10 to the power minus 3 in order to convert it into meter. A is what? It's 0.45 in this case. So let us take it as 0.45 millimeter, convert it into 10 to the power minus 3. And then what is the x? 1.5 meter. Keep it as 1.5 meter. So the wavelength, you can find out. It will come in a meter, but you can convert it into nanometer. Because normally we use it in nanometer. Lambda is 600 nanometer. So this is how we operate as far as the single slit is concerned, right? Okay.